Well, we're doing question 9 that says given h of x is equal to negative x to the power 3 plus ax squared plus bx and g of x is negative 12x. P and Q are the turning points of h. The graph of h passes through the origin. Now, in the previous videos, we did question 9.1 and 9.2. Now we're going to do question 9.3. The question says that show that the concavity of h changes at x is equal to a half. All right, there are some rules for the concavity. I'm going to move my board over here. 9.3. So now we need to show that the concavity of h changes at x is equal to a half. Okay, so it means that we need to prove that on the left or right of h it's concave up or concave down. Now, to prove that, it's when we show that the second derivative is lesser than or equal to or greater than. Now, first of all, we had like we did find that h of x was equal to negative x cubed plus 3 over 2x plus 6x. Okay, and then h prime of x will be then negative 3x squared plus 3x plus 6. Okay, then h derivative of x, the second derivative will be then negative 6x plus 3. Now we can take 3 as a common factor, and then this will be okay, I can take negative 3 as a common factor then. So this will be 2x minus 1. Now, I want to set this is equal to 0, okay? Because the second derivative, I want to set it equal to 0. That means 2x minus 1 equal to 0. That means x is equal to a half. So this value of x equal to a half is the value that determines the concavity of the equation. If I solve, for instance, a half over a half like in the function, so if I sub a half in the function here, we're going to substitute the value of x here into into the second derivative. Okay, excuse me. This means okay, let's just solve the number line. If you have number line over here, the value of x is equal to half. This proves that this part must be either positive or negative. Okay, now let's say negative and positive. But now let's check. If I pick up a value lesser than a half, before even I do that, let's just pick up a value lesser than a half. A number like a value like 0, for instance. 0 is lesser than a half. I will substitute that in the second derivative. Okay, and then if I sub in there, what we have, we will get, if I sub 0 over here, let's say 0 over here, we get a positive. Okay, and then if I sub a number like 1 over here, I sub 1 there. Instead of over here, I sub 1 for x, and then we get a negative value. So this determines that at the value x is equal to a half, h of x, okay, I want to see here, if x is less than a half, h of x will concave up, okay? H of x will concave up. So it concave up if the second derivative is greater than 0, and then concave down if the second derivative is less than 0. So, but here I will say if x is greater than a half, h of x concave gave down. Thank you.